again. There's been a lot of talk among teachers on whether or not students will be given a formula sheet for the AP Precalc exam. They will not be given a formula sheet for the AP Precalc exam. And when you're thinking about formulas, like what formulas should students know, I think for this course, it really boils down to trig identities. There are really 11 trig identities that students should know for the AP Precalculus exam. And if you're thinking, that's ridiculous. I've always given my students formula sheet when we get to verifying trig identities, etc. There's really two different perspectives that you can take in this regard. You can think about the fact that, oh yes, there are 11 identities that you need to know, students, and now you need to memorize them for the AP Precalculus exam. Insert groaning and eye rolling. Or you can say, hey, you guys, guess what, there are 3 identities that you need to memorize for the AP Precalc exam. And if you know those 3 identities, it will unlock 8 other identities. So memorize the 3 and you'll be able to use a total of 11 trig identities. So if you're not quite familiar with the trig identities, let me just show you a quick way that you can take 3 identities and derive them to unlock a total of 11 trig identities. We're going to start with the CED. As with pretty much everything in AP Precalculus, we refer to the CED for our source document. And in topic 312, you see equivalent representations of trig functions. This is where all of the trig identities that students need to know for the AP exam are listed. So in 312A1, it lists the Pythagorean identity. And then in A2, it lists manipulations of the Pythagorean identity that can result in other trigonometric relationships. Now we'll look down, and in 312 part B, it talks about some identities for sine and cosine. So there's 2 more identities. And then in B3 and B4, it talks about the double angle identities for sine and cosine. And then in B4, it talks about just verifying trig identities using the previous identities that we've talked about. Now, if we continue on to the rest of this topic, you'll see in 312C, we're talking about using equivalent analytic representations of trig functions. No other trig identities are specifically listed here. So let's just start with the Pythagorean identity, I guess the fundamental Pythagorean identity. If you take this identity, sine squared theta plus cosine squared theta equals 1, and divide all the terms by sine squared theta, then you have 1 plus cotangent squared theta equals cosecant squared theta. So there is the second of those Pythagorean identities. Let's say instead that you start with the fundamental Pythagorean identity, but you divide everything. Instead of dividing by sine squared of theta, you divide by cosine squared theta. Well, now you have tangent squared theta plus 1 equals secant squared theta. So if the student just memorizes the fundamental Pythagorean identity, then you can easily see how the other 2 can be derived, not by memorization, but just by simply dividing all the terms by either sine squared theta or cosine squared theta. And we could dial it back even farther. If you don't want the students to memorize the fundamental identity, just take it back to the Pythagorean theorem. X squared plus y squared equals r squared, and change that into cosines and sines, and then go from there. So anyway, there is the fundamental Pythagorean identity and its 2 derivations. Now let's go over and take a look at the sine of alpha plus beta identity. So if the students memorize the sine of alpha plus beta, then they will also be able to find the sine of alpha minus beta, because of course alpha minus beta is the same thing as alpha plus negative beta. So let's go in and substitute beta with negative beta in this sine of alpha plus beta identity. And let's simplify. So sine of alpha, and then we get to cosine of negative beta. So think about a negative angle and its cosine compared to the positive angle. It would have the same cosine. So we'll just simplify that and call it cosine of beta plus cosine of alpha. And now we get to sine of negative beta. Well, now thinking about from the y perspective, when the angle is negative, its y value will be the opposite. So the sine of negative beta would be negative sine of beta. So since this is negative sine, we'll call this negative sine of beta. We can rewrite this as sine of alpha cosine of beta minus cosine of alpha sine of beta. And so there you have the identity for sine of alpha minus beta, not because we memorized it, but just because we know about reflections on the unit circle, and we can easily get from one to the other. Okay, so now we've got sine of alpha plus beta and we have sine of alpha minus beta. The next one that we can derive from that same identity is sine of, let's say, 2 alpha, because that's the same thing as sine of alpha plus alpha. So using the identity sine of alpha plus beta, we will substitute instead of beta another alpha. Now, because of the commutative property of multiplication, we can rearrange the terms and call that second term there sine of alpha cosine of alpha. And now you see we have like terms. When we combine those like terms, 2 sine alpha cosine alpha gives us the identity for sine of 2 alpha. So again, if the students memorize the identity for sine of alpha plus beta, they are able to derive sine of alpha minus beta and sine of 2 alpha. So then let's take a look at the identity for cosine of alpha plus beta. So again, we're going to ask the students to memorize this identity, but when we want the students to use cosine of alpha minus beta, and thinking about this again, if beta is negative, its cosine will be the same as the cosine of positive beta. So we'll just change this to cosine of beta minus sine of alpha. But again, the sine of negative beta and the sine of positive beta are opposites. So we will call this negative sine of beta. And of course, that's going to make cosine of alpha cosine of beta plus sine of alpha sine of beta our identity for cosine of alpha minus beta. Okay, so there we have the identity for cosine of alpha minus beta. Now let's take a look at cosine of 2 alpha. So that would be, well, the same thing as cosine of alpha plus alpha. So cosine of alpha minus sine of alpha sine of alpha. That's cosine squared of alpha minus sine squared of alpha. And You can always use the fundamental Pythagorean identity and replace cosine squared of alpha with 1 minus sine squared of alpha. When you combine like terms, you have another identity for cosine of 2 alpha, 1 minus 2 sine squared alpha. So that's another identity for cosine of 2 alpha. Likewise, you can go back to cosine squared alpha minus sine squared alpha. But let's replace this sine squared alpha using the fundamental identity again. So cosine squared alpha minus 1 minus cosine squared alpha. Distribute the negative. And combine like terms, and you have 2 cosine squared alpha minus 1, which is another identity for cosine of 2 alpha. So let's take inventory right now. 1, 2, 3, 3 identities. Oh, 4. 4 identities just came off of memorizing cosine of alpha plus beta. 2 other identities came off of memorizing sine of alpha plus beta. 2 other identities came off of memorizing sine squared theta plus cosine squared theta equals 1. So again, do the students need to memorize all of these identities? No, they need to memorize 3 identities, but be able to derive the other identities. So less things to memorize, more understanding. I hope things continue to go well for you in AP Precalculus. Couple of things. New mentoring groups are forming for the spring now. So if you're interested in joining an AP mentoring group, it's a group of 5 AP Precalculus teachers with an AP Precalculus consultant. We meet 1 hour a month virtually. It's been a really great experience for teachers to share great ideas that they're having, for you to just kind of connect with other AP Precalculus teachers throughout the country, and to have the AP consultant to bounce some ideas off of. So if you're interested in that, just Google AP mentoring and sign up for a group for the spring. The other thing is we still are looking for readers for the AP Precalculus exam. This would be the greatest professional development opportunity for you. You would learn so much about the curriculum and about how the exams are scored, and it's just a great opportunity for you to collaborate with other AP Precalculus teachers and people in the know with AP Precalculus. So the reading this year will be both conducted in person in Kansas City and virtually. We need readers for both. So if you're interested in either of those things, again, you can just Google become an AP reader, and I'm sure you can find the right link to sign up for that. So lastly, remember to follow my YouTube channel, Miss Hemi's AP Precalc. I hope things are going great for you, and we'll see you again soon.